be continuing with elementary operations. Elementary operations on matrices. Elementary operations on matrices. So this is going to be kind of a very different topic from what we have done before on matrices, because so far we have done addition of matrices, subtraction, multiplication, the basic things. So this is going to be something new for us. So we're going to begin very soon. Shipomala, Patigrino, Lanlina, and all. Yeah, good evening, all of you. Priyanshu. Good evening, Imlimola, Alamnola. Some names actually I cannot pronounce. It's like too lengthy and all, but doesn't matter. As long as you're coming and joining and learning in the class, that's all that matters. Avila, Imsunola, Himanshu, Imtisina, Sangita, Nasalla, Kinkali. Okay, so yeah, joining in slowly one by one. So you can just get ready with the heading. That's Nakshiballah. Yeah, everyone, good morning. Not morning, it's getting habituated to morning. No? Good evening. Good evening, all of you. So we are going to do a very different topic today. Okay. It's about elementary operations. So yeah, please don't be Ato, Kere, Otimongla, yeah, all of you, a very good evening to each and every one of you. So in the beginning, especially this topic might seem to be, right from the beginning, I do not want to start on a negative note, but a fact is a fact, so I'll have to put it straight up. So in the beginning, this topic is going to be slightly, a bit confusing, maybe, but don't worry, that's why I'm here. All that confusion will be definitely removed, and yeah, I'll give you some hints and tricks also. So using all of those tricks and tips and all, definitely. And yes, many say that I am there, so I can help you. Don't worry, I'll give you exactly, yes, yeah, I'll try my level best, but we all know ultimately what matters, it's actually your practice only that will matter. So I'll try my best to give you the methods on how we shall do this, the tricks and the tips and the concepts and whatever is required. Definitely I'll be giving it to you. But yes, ultimately at the end of the day, as we all know, it all depends on you only. So you'll have to go back just again, once the classes are done, you have to go back, start your revision again, practice many questions, and yeah, ultimately definitely you will get, start to see the reality, once you start your imagination and all, then it becomes interesting. Okay, so yes, let's get back to all of you. Some more have joined. Very good evening to all of you. That morning word is still stuck with me. So all right, then let's just begin. Yes, before I begin, if you haven't given a like, please try to give me a like also. Chalona. Please try to give me a like also. That is also very important. Okay, anyway. Elementary row transformations, elementary operations on matrices. So now here what happens here is inside the matrix, what you can do is you can apply some transformations that can be done. Okay, like it can, row transformations also can be done, column transformations also can be done. That's like, for example, like, of course I'll give you some of the details. But some examples, like within the matrix, like you can interchange the rows also. That is also possible. You can interchange the rows or the columns, or maybe you can even like add a particular row to another row. You cannot do a row to a column. That's basically not done. But column to a column you can do, row to a row you can do. So these are some operations which you can do. So in brief only about all these in details. Next, along with this, today the topic, that most important topic that we are going to be discussing, is about the inverse of a matrix. Inverse of a matrix, that also will come very soon. Inverse of a matrix, so that's also going to be very important. But as I say right in the beginning of the matrix session, I've said that there are many more theorems and formulas and stuff that we do in matrices and all, but we are not going to be doing all those in details here. In class 12 standard, we are here just to give you some of the concepts, the basic ideas, how to proceed, the basic things. The rest of the things you will be learning in your higher classes as you move up. Okay, so there are some certain things which we'll have to just ignore. We'll just have to move on. All right, just to get the formula, we'll have to just move on. All right, those formulas, definitely verification, proof, all that you will do in your higher classes. All right, now elementary row operations. Of course, we have two kinds of operations. That is in brief only. Okay, in brief only I'll be giving you. We can have two kinds of operations in a matrix. That is, we can go for elementary row operations, or we can go for elementary column operations also. Some of the basic operations that we generally follow, at least on 12th standard and all, is we can exchange the rows and the columns, and that is how we will be writing it, denoting. No, that is something that we can do. I can interchange rows and columns. As I say, I don't want to be going too much into the depth of all this, but yeah, we can exchange. As we solve more problems that time, of course, you will see the varieties of operations that we can apply using this basic operations. Okay, so similarly, column also, I can interchange columns and I can interchange column. For example, just one example, roughly 1, 2, 3, 4. So if I just want to, this is row 1 and this is row 2. So what I can do here is, the value of the matrix doesn't change. Okay, for that, of course, after this, the next topic that comes is determinants. So definitely we'll be moving there also. So there again, we'll be learning a lot. What I can do is I can exchange R1 and R2. I can exchange. This is a notation that we generally use. I can remember, these are not absolute. Okay, there are many notations can be there. It's like different ways. So R1 and R2 I can exchange, like R1, R2 I can exchange. That is like 3, 4, 1, 2. Yeah, yes, definitely, yes, it can be done. These are called operations, transformations. We have row as well as column also. All right, so we can exchange rows and columns. Don't worry, the value of the matrix will not change. Will not change. Another thing that we can do is a particular row can be expressed as the sum of two matches, two rows. It can be expressed as an addition of 2 or more rows. That also can be done. Another, like I can add like R1, I can represent as R1 plus R2. Similarly, Ci also can be expressed as Ci plus or minus Cj. That can be done. That means I can, for column 1, I can add up column 1 and column 2. That also can be done. Don't worry, the value will not change. Another operation that we can also do is I can multiply a scalar to a particular row of a matrix. That is k times of Ri. Yeah, that also can be done. I can multiply elements of a row by a non-zero number. Similarly, elements of a column also can be multiplied by a non-zero number or a scalar. Okay, so these are some of the operations that we can basically do. Yes, of course, there's a continuation of this second operation also. Like the rows also can be written as addition or subtraction of a scalar multiple with another row also, Ri plus minus 5 times of, like something like R1, I can like evaluate, I can represent as R1 plus 2 times of R2. Like this kind of operations can be done. Yes, I'm getting it. Please worry, don't be confused as we solve more problems. Definitely all those confusions will be clear, but these are the operations that are possible. Okay. All right, so It depends on the question. We can go for column operations or we can go for row operations. But if you're going for column operations, then you'll go for only column operations. If you're going for row operations, you can only go for row operations. You cannot do both simultaneously. No, that's not allowed. But basically in class 12, and especially with this basically NCRT textbook and NBAC, now in board of school education, we generally focus on row operations only. Of course, when you go to determinants, your column operations also are done, but for this topic, to find out the inverse of a matrix, we focus on row operations only. All right, so that's easier for us. We'll be focusing more on row, but the same operations that we apply can be done in a column by using column operations also. All right, so definitely, but the question will be given to you like using elementary row operations. They will be specifying that. Okay, if nothing is specified, if they just say like using elementary operations, find the inverse of a matrix, then it's all right. You can use either column or you can use either row, but they will be specifying using elementary row operations or using elementary column operations. They will be specifying that. Okay, so we'll have to stick to that. Now moving further, what we have here is like invertible matrices. Now what is this again? Invertible matrices. We're going to learn a lot of new stuff here. That's why, as I said, today's class, yes, I'm not going to be lying to you. Definitely, as a teacher, definitely we will tell you that, hey, it's easy, don't worry, it's very, very easy, Aram, say you can do and all. No, I'm not going to lie to you because we were also students and also once upon a time, we were also students, definitely. So this topic definitely is going to get a little bit confusing. Okay, there will be confusions, definitely, but as I always say, if there are confusions, then that's good. That means you're working on it. All right, and you keep on working on it, those confusions will be gone. Okay, but don't give up. That's what matters. No, don't give up. You keep on doing. Be consistent and determined also. All right, but I'll try my level best, definitely within my limited knowledge. I'll try my level best to show you this. Now, these invertible matrices, as always, maybe you can just write on a definition. Like again, very important. Invertible matrices, inverse. We all know the basic meaning of inverse. So a square matrix A of order n. Square matrix, so that's why I'm just writing the order n only. So if it's order 2, then it means a 2 by 2 matrix. I guess you know that already, isn't it? 3 means 3 by 3 matrix. The square matrix A of order n is said to be a square matrix A of order n is said to be invertible if there exists, okay? If there exists a square matrix of same order, definitely. If there exists a square matrix of same order such that if there exists a square matrix of same order such that the matrix A into that matrix B will give you an identity matrix. Square matrix of same order, so it will be conformable, definitely don't worry about that. Or even this also, B into A. Definitely they will be conformable because they are square matrices, so A into B or B into A, yeah, definitely they will be conformable. So if you come across this case, then what we say is that then B is said to be the inverse of matrix A, denoted by A inverse. Denoted by A inverse. So if you come across any such matrix of the same, definitely of the same order, if you come across any such matrix where you have that matrix, you come across another matrix, you multiply those two matrices, we end up with an identity matrix I. Then what happens is B is said to be the inverse of the matrix A, denoted by A inverse. But let me remind you that the inverse of every matrix does not exist. Okay, there are certain matrices, some matrices whose inverse do not exist. How do I identify that? Yeah, that in brief today I'll be telling you, but when we go to determinants in detail, we'll be discussing about that also. All right. So it's basically something like, if you remember, multiplicative inverse. So what was a like, say if you have a 3, then what was the multiplicative inverse of 3? It was 1 by 3. So that because 3 into 1 by 3 would give us the multiplicative identity 1. So it's a similar concept to that only. Okay, so a matrix into its matrix, if it gives us the identity matrix I, then that matrix B is said to be the inverse of the matrix A, denoted by A inverse. Alright, there are basically two methods to find out the inverse of a matrix. That is, one is using the determinant method, which definitely is a little bit easier. But we are not going to be doing that now. We'll do that when we go to the next chapter. Today what we are going to do here is we are going to learn how to find out the inverse of a matrix using elementary row transformations. So this will depend completely on your imagination. So what are we going to do here today? We are going to learn how to find out the inverse, that matrix B, the inverse of the matrix B, the inverse of a matrix A by using elementary row transformations. Column also possible, but we're not going to be doing with the column transformations here. We're going to be doing with studying with using row transformations only today. We have already seen the condition about invertible matrices. What is that? The first condition, the condition is that the matrix, that particular matrix, when you multiply it with our given matrix, should correspond to I, or in the vice versa also, B into A. So the product of those two matrices, our given matrix and our matrix, which is expected to be the inverse of a matrix, should be I. Alright, so let us begin. Now basically, as I said, the theorem, the formula to the procedure to this, we are not going to be discussing that because that proof generally is not asked in the board exams and all. So, and yeah, but definitely you'll be learning that if you go to your engineering higher classes, you're going to be learning all of that. We are just going to use that result here. Okay, we're just going to be using that result here. How do we do that? That is, if a matrix A is given, okay, if a matrix A is given to us, what we do is, the first step is we shall write, we shall write like this. We will prepare the matrix in this form. That's the first thing that we are going to do. Just the procedurally is important here. That is, when a matrix A is given to us, I will be writing that in this form, that is A equal to I into A. Of that particular order, 2 by 2, 3 by 3, that will be given to us in the question. After that, what we are supposed to do, please try and understand this. Okay, what we are supposed to do, as I said, we are not interested in the proof of this result. We are just going to be using this result. Okay. What we are supposed to do is we have to now apply some elementary transformations. What kind of transformations? Now that will be unique depending on the question. Alright, so what we are going to do is we have to apply some elementary transformations. We will have to keep on applying elementary row transformations on and on and on till we come to a certain situation, where this A, after applying, where this A changes to I. This A, after applying those operations, that is our motive. So our motive will be I will be using elementary transformations, different varieties of transformations that will be unique for every problem, for every person, every teacher. It's going to be unique steps, different steps. And then ultimately I'll convert this A to I. Along with that, what happens is that part, the elementary transformations, row transformations that I apply on every step with the matrix A, those same operations should be also applied to the matrix I. So I started with an identity matrix here. So as we go on applying the same operations to this matrix and this matrix, this I definitely will no longer be an identity matrix. Now it will go on changing and changing and changing and changing, and definitely at that point where you get this as I, you will see that this matrix has changed into a different matrix, not identity matrix. And what about this A? And this is just a showpiece, nothing else. You will not apply any transformations. We're just going to carry on with this because that verification of that theorem, that is A, B equal to I equal to B into A, actually comes from A inverse theorem, like A inverse A applying, it goes on like that. As I say, we are not going to be going for that particular proof, so let me not confuse you with the proof also. So, got it? Once again. Once you're given a matrix and then they tell you to find out the inverse of a matrix, what we shall do is write this step. Okay? After that, I'll start applying elementary row operations. Go on till I convert A to an identity matrix, I. But the same operations will also be applied to I, that identity matrix. So this I keeps on changing, turns out at the end it will change into a new matrix B. A, we are not going to be applying any operations, we will continue as it is. Then once you get this result, that was the theorem, about invertible matrices, that condition. Once you get to this result, what does it prove? It just proves that A into this matrix, A is our given matrix, A into that new matrix, the result proves that only, isn't it? See, A into this matrix is what? I. That means this B is nothing but the inverse of our given matrix. That's the concept, that's the theme that we are going to be applying. Alright, of course it's a lot different when we start applying and all, but yeah, that is what we are going to be doing. So if we know in advance what are we going to do, then it's always easier for us, right? Once we know our destination, definitely we'll reach. Once we know where we are going, definitely we will reach our destination. So that's what we are going to be doing. Okay, enough of the lectures. Yeah, but before that, again, as I say, there's one theorem. We're not going to be proving that, don't worry, I told you we are not going to be proving any theorems, but this is important. Every invertible square matrix, has a unique, this is also known as the uniqueness theorem, okay? This is also known as the uniqueness theorem. So what it says is every invertible square matrix has a unique inverse. Every invertible matrix has a unique inverse. Hello Chati, good to see you after such a long time. Finally you are here with us. I thought that you had gone back. So it's good to see you Chati again here. So every invertible square matrix has a unique inverse. This is known as the uniqueness theorem. That means if there is a matrix A whose inverse does exist, then definitely its inverse will always be unique to itself. That means like I cannot have 2-3 different varieties of inverse for one matrix. No, for one matrix, if it exists, there's only one inverse. Alright, you cannot have 2-3 inverses, inverses, let me put it in the plural form, inverses for just one matrix. One matrix, just one inverse. That's why it's called the uniqueness theorem. Unique means one, no, in mathematics basically. So just one matrix only, one inverse only. All right, but the condition is every invertible matrix. And as I had told you earlier, that every matrix is not invertible. Now, how do we really get to know whether a matrix is invertible or not? Now, for that, of course, just for the time being, for now, we will just jump through that particular topic because the next topic that we are going to be discussing very soon is determinants. So there, of course, we will be learning, but it comes from this topic. Determinant of a matrix. Don't worry, we are going to be studying this in detail again. That's in the next chapter. Okay, we're going to be studying about this in detail, which is in the next chapter. So determinant of a matrix. So whether the inverse of a matrix exists or not, basically is defined by its determinant, which we denote by A. Now, of course, this came out all of a sudden because I expect that there will be definitely some questions in the exercise also whose inverse may not exist. Now, what shall I do? Okay, anyway, I'll try my best because next topic we're going to be studying again. So after that, again, you can come back and you can just do again. Now, how do we find out this determinant? Now, determinant, okay, a trailer for the next session, next video. Determinant is nothing but just a value of the matrix, value associated with the matrix, something like magnitude, something like magnitude of a matrix, a quantity associated with a matrix, something like that. Okay, determinant is just a value only, value of a matrix, let's put it like that. All right. So for a 2 by 2 determinant, let's say A, B, C, D. For a 2 by 2 matrix, I'll just show you a 2 by 2 matrix. For a 2 by 2 matrix, let's say if this is our matrix A. So for a 2 by 2 matrix, how do we calculate? The determinant is like this sign, determinant, just like the value sign for magnitude, absolute value. How do we calculate? How do we calculate is we just cross multiply. For a 2 by 2, 3 by 3, it's slightly complicated. That's why, yeah, we will be discussing that very soon. What we do is we cross multiply A into D minus B into C. That's how we calculate the value of the determinant of a given matrix. Very quickly, one example. Let's say, suppose I have to calculate the determinant of this. You have to use this sign, okay? But yeah, let's say 1, 2, 3, 4. So how do I calculate? Yeah, I'll multiply. 4 ones are 4 minus 3 twos are 6. So 4 minus 6 is how much? Minus 2. That's why I was telling you determinant is nothing but the value associated with a matrix. Okay, just like the magnitude of a vector quantity, something like that. Alright, so okay, now you can just write it roughly because definitely in the next session we are going to be studying a lot more about this determinants also again. So the inverse of a matrix, whether it exists or not, basically is defined by the determinant of a matrix. How? Simple rule, that is, if you have a given matrix and if the determinant of the matrix A is 0, there's a topic called singular and non-singular matrix, which also we will be discussing again. So if the determinant of the matrix happens to be 0, then what happens is A inverse does not exist. Only if the determinant of the matrix A is not equal to 0, A inverse exists. Okay, so that's what, that is the condition. Alright, so we'll keep that in mind. Definitely we're going to be learning a lot more about that later. Alright, so enough of the discussions. I guess some of you must be really bored. Let's go to the exercise and let's see what we really mean by this. Let's go to the exercise 3.4. Let's start with, let's say, number 1. The matrix A is given. 1 minus 1, 2, 3. Okay, let me just put the middle because I need a lot of space for this, something like this. Alright. I guess that's the middle almost, isn't it? Alright. Ready? Chalo. What are we supposed to do? First step. Write it properly in terms of rows and columns, okay? हो गया? Chalo. But I'll be rubbing this again because I need more space as I said, so I will rewrite that once again since you must have already written it. What are we supposed to do? We are supposed to convert this using elementary row operations, sound operations which I gave you. I'm sure you are still very confused how to use that, don't worry. We're going to apply blah 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 till this one changes to like this. This one changes into some kind of a matrix. This one we are not going to be doing anything. Then once we get this condition, we will say that this is that inverse of the matrix. Of course, you can go for verification also because your matrix A, if you multiply it with this particular matrix, you will get I. That's verification also. That also can be done if you get time in the exams. Basically, these questions, if they come, definitely should be of 4 marks or 6. Alright, now there are a lot of tricks and a lot of tips which we apply. Okay, but there is no hard and first rule or a tip which is going to be completely, just defining and then making your problems just like in one step you'll be able to solve. No. Of course, yes, using determinants, we can easily do that, but once the question says using elementary row transformations, there is no way you have to do it. So you cannot be lazy here, okay? There will be lots of multiplications, additions, arithmetic, addition, subtractions, nothing much but addition, subtraction and all. There will be a lot of stuff that you will be doing. You'll have to be extremely careful, about which even I also cannot promise for myself. I'm also very careless, you know that, when I do it on the board. So let's try to do that. So, but yeah, I'll be giving you some tips and tricks of what I know, what I use, what I think there are many, okay, but as I said, you can also have your own tips and tricks because this will vary from person to person, okay. So you can just try mine also, then that might, not mine, but try the method that I give you. So I did not discover it, so definitely it's not mine. So I also learned it from my teachers and through practice and through different textbooks and so on. So now we shall apply different kind of operations. But what happens here is once we start applying the operations, this is just a 2 by 2, so it's going to be simple. Most of the times what happens is in the midway we lose our way because there is a lot of confusion. Okay, we lose our way. So just to avoid that, what you can do is, one of the best tips or tricks that I've come across in my experience is this. You are not going to focus on this. Let it change. This is meant for change. Let it change. Alright, let that change. Don't worry about that. Let it change. Worry about this. What I basically do is, instead of just focusing randomly on different numbers, what I basically do is, see, this is a 2 by 2 matrix. So what I have to do is I have to convert this as 1, 0, 0, 1 by using elementary row transformations. So what I do here basically is this. there are some more also. I start focusing on this element first. That's to convert this to 1. I forget about the rest of the elements. Then I move on to this element. So this element I'll have to turn that to 0. In that meantime, what happens with the other elements, I'm really not interested much. Then I move on to this element. I try to convert this to 0. Then I come back finally to this element, which, I mean, this is not going to be 0, this is going to be 1. And then finally I come back to this element, which I'll be converting it to 0. So if you proceed systematically like this, then like you will not lose your focus. Okay, once you start solving this exercise, you will get to know what I mean. Alright, so let's begin with more problems. We'll focus again. So now, of course, you might not be really getting what I'm trying to tell you here, but anyway. Now, as I say, I'll write this here. What will I try to do? I will try to convert this as 1, which is already there. So I don't have to worry about this. So that means row 1, I'm not going to be changing as of now. So write down row 1 as it is, because it's already 1 here. That's why I say, do not worry about the other elements. Just focus element wise. Now my job is to convert this to 0, this element to 0. What can be done? You'll have to use the rows, of course. Okay, you just cannot turn it to 0 on your own. Kushi, no, that's not possible. You'll have to use those operations which I gave you. So what can I do here is, how will I convert this to 0? Look carefully. If I apply this operation, if row 2, if I apply this operation, row 2 minus 2 times of row 1, corresponding elements. Row 2, if I apply the operation, row 2 minus 2 times of row 1. Now you see what happens. I'll just do it here. Row 2, element wise. So first element 2 minus 2 times of 1. So that's like 2 minus 2. That's of course C, 0. Done. But automatically here also same operation will happen. So 3 minus 2 times of its corresponding element R1 minus 1. So that's like 3 minus plus 2. Fine. Same operation has to be done here. Next, 0 minus 2 times of R1. So that's like minus 2. Here, 1 minus 2 times of 0. No, 1 minus 2 times of 0. That's the operation that I'm applying. What do I get? 1. So by all those operations and this and that, this is what I meant. Row operations and all. Alright? Okay, this is written down. You have to do this in the rough, okay? Don't try to do it mentally. One small mistake, remember, finish, game over. One small mistake, that's it. Rest of the steps will all now be just gone. So don't do that. Done? Okay. Alright, done? Of course, you'll have to show this operation just by the side, okay? You have to show this operations, which operation you're applying. Now, my job is done. Next job, what will I try to do is... See, this is also done. This is also done. Next, what will I do? I focus on this. So this I will try to convert to 1. What element is that? This one, 5. If you like fractions, you can, that means again row 1 I'm not going to be changing. So row 1, let it be as it is. Row 2 I'll be changing. What can I do? Directly, of course, if you like fractions, if you think you're careful, directly what I'll do is row 2, I will divide by 5. That's what I say, no, in that operation that Ri, it can be multiplied by a scalar also. Scalar means what? Multiplied by a scalar means I can multiply 1 by 5, I can multiply 2, I can multiply 10, I can multiply by 1 by 25. That can be done. So what I've done is if I divide by 5, 0, this is 1. So job done. Here, of course, same operation, I'll have to divide. So it's minus 2 by 5, this is 1 by 5. हो गया? I don't need this. Now finally, I have to convert this to 0. Which one is that? This one. So I think now you can use your imagination. What can be done? Of course, yes, we'll have to use the rows and columns only. I mean rows only, sorry. So what can be done is very simple, I guess. Now you can guess. That means row 2 to ho gaya na? Now only row 1. So row 1, see, minus 1. So if I add this with this, row 1, if I apply the operation, row 1 plus row 2. So this will not be affected because you have to keep that in mind also. Whatever operations you are applying with whatever row, you have to see to it that the values which you have already changed doesn't change again, because again then you'll have to go back and do again. Alright, so you should keep that in mind. So here no change. Minus 1 plus 1, 0. So 1 plus minus 2 by 5. So 1 plus minus 2 by 5. So that's like 1 minus 2 by 5. That's going to be 3 by 5. 0 plus 1 by 5. That's 1 by 5. Okay? So you see, we have that situation. We do have that situation now here where we have this, that you see that, that's why you can go back, you have your notebook, so it will be written in one page. You can see at the top we started with A, do operation. Okay, now convert I. So this is now in the form of I equal to B into A. That means A into this matrix will equal to now, it will give me an identity matrix. So therefore A inverse is this matrix B, that is 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. That is the logic. That is the concept involved here. Nothing much. The only problem that you will face here will be your imagination only. The only problem that you will face here will be your imagination, because concept is very simple, that's what we are supposed to do. But the thing is, there will be confusions. That's why, as I say, try not to lose your focus. Try not to look into so many rows and so many columns. This is just a 2 by 2 matrix. We have a 3 by 3 matrix also. So don't try to look into too many, the elements, too many rows and all. No, as I say, just focus one by one. Forget about what the other elements are doing, whether they like you or not. Forget about that. You just focus on your goal only. So that's basically in life also that matters, isn't it? If we focus too much on what others are thinking of us, then definitely we will not grow. So likewise, just focus on the elements. Definitely you will keep your focus, and this is one of the best ways to solve this. Some of the other ways are like we start focusing on just one row, so we really don't worry about what happens with the other rows. So we just focus on one particular row. That's one way of doing it. That is also possible, definitely. So there are many ways, many tricks that generally we apply. This, I personally, of course, I found this to be the most, one of the most, not the most, but one of the most convenient. Okay. Alright, one more, chalo. Number 5, randomly, let's pick up questions. I am going to write down the equation directly, okay? Directly. So, 2, 1, 7, 4. 1, 0, 0, 1. A. Ready? So this is also a 2 by 2 matrix. So I'll write down here 1, 0, 0, 8, 1, 0. Let us begin. That's why you cannot memorize these steps, okay? That's not possible. You cannot memorize, because every invertible matrix has a unique matrix, inverse. So every question, different steps. The previous question that I did, if I do it again, maybe I'll be using some other steps again. So these are steps which we cannot memorize. Chalo. Now my job is to convert these to 2. I mean to 1. So what can I do? What can I do? Yeah, if you, maybe we can directly divide by 2, but like as one opinion, one advice, try to avoid fractions as much as possible, okay? Because yeah, there will be many cases where you cannot ignore fractions, but try to avoid fractions. Okay, try to avoid fractions. Yes, Hilal said -1, but I just cannot do -1. No, I have to involve the rows. Remember, elementary row operations. I have to involve rows. So I just cannot put like -1. Kushi to nahi chalega na. -1 I just cannot do. So what can be done? Look at this. I have to use the operations, elementary operations. Otherwise that will be too easy, man. If I just convert in one step, we'll get the answer. So R1 R2 minus 3 times of R1. Will that work? R2 minus 3 times of R1. These are all the varieties. It's just that you just cannot put in new terms all of a sudden. So R1, R2 I'm not going to be changing. So R2, let me write as it is. Whichever row you don't plan on changing that moment, write it down so that again that confusion is removed. Alright? Alright, let's focus now. R1, what am I planning to do here? R2 minus 3 times of R1. So that's 7 minus 6, 1. Yes, of course, we can add and subtract with k, but with that, of course, you have to include one r again. You have to include one row again. Okay, you have to include. I just cannot do like this. R1, I can just like 1 plus R1. No, that's not possible. Can't do that. You have to include definitely a row again. R2, R3, whatever be, you have to include rows. Alright, you just cannot do that. In that case, too, you will be changing the whole structure of the matrix. So that we cannot do. Yeah, you got it. Thank you, Hilal. Yeah, it's good. Again, thank you for that clarification, because I believe some of your friends also had that same doubt. So because of you, now that doubt will be clear. All right. Otherwise, definitely during the exams, we see different kinds of operations. Okay, some we are very surprised, and now first time we see those kind of operations. So hopefully, because of that, I guess we will not be seeing those operations. Enough of the talk. Okay, same. R2 again, go for now for this one. Nah? It's R2 minus 3 times of R1. So 4 minus 3, 1. Same operation here. So for R1, I'll have to apply R2 minus 3 times of R1. So minus 3. 1 minus 3 times of R1. That's why I told you right in the beginning. It might get a little bit confusing in the beginning only. I did not say that every time it will be confusing. No, in the beginning it might get a little bit confusing. Do not worry about that. I'm here to help you out, but these are the only tips that I can give you. There are many more again, but let's not confuse with too many tips and tricks and all that might just confuse us. Let's stick to one. Practice, 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 practice. You'll be good one day. Okay, I'm removing this step now. So one job done. Next job, I shall now focus on what? This to ho gaya 1. Now I shall focus on this 0. So how do I convert this to 0? That's simple. R2, I'll just write R2 minus 7 times of R1. We can exchange that also. You can like 7 times of R1 minus R2. That also can be done. This and that too can be done. So I don't plan on changing R1. I'll leave it as it is. Alright, let's begin. R2 as R2 minus 7 times of R1. So 7 minus 7 times of R1. So 7 minus 7, 0. Here, 4 minus 7 times of R1. So 4 minus 7, minus 3. Similarly here, I don't need this step. I'll do here 0 minus 7 times of R1 minus 3. So that's like 0 plus 7 3s are 21. So this will be 21. This 1 minus 3 times of R1. So 1 minus 3 minus 2. Okay? Alright. Very good evening to all of you, those who are joining now. Very good evening. Now this part is done. Next, again, focus moves to there, which I'll have to convert to 1, isn't it? See, that way you can keep your focus, no? So that way you will not be confused, okay? That way you will not be confused. Otherwise, most of the times, we lose our way as we proceed with the solutions and all. So, chalo. What can be done? Maybe I can divide by 3, but as I say, I will try to avoid fractions. If possible, okay. Very tempting, I know, I understand, very tempting, but I'll try to resist. So again, first row I'm not going to be focusing. I'll be focusing on the second row. Now let me remove this. What if I apply R2 as what can be done? Okay, maybe we can just divide by minus 3 also, no problem. Or because if I do this, that's alright, but this value should not change again. So maybe okay, no worries, let's just divide by minus 3. So 21 divided by minus 3, that's minus 7. This one minus 2 by 3. So no minus 3, so this will be plus 2 by 3. If you see any careless mistakes on my part, please do let me know. Okay, I'm very good in making mistakes. I have a small doubt, especially with this. I hope I did not make any mistakes so far. Alright? Okay. Let me just go back once. Let me just confirm. So R2 was 7 times of R1. So fine. Anyway, let's just continue. So now the focus is on this to convert that to 0. That's why it's very easy to lose our way. Okay, so 0, 1, minus 7, 2 by 3. Did we do this correctly? I have a small doubt with this. Please bear with me once. You can just check your steps once. In the meantime, I'll just quickly do this. So 7 minus 6. 1, 4 minus 3, 1. That's no problem. 0 minus 3, 1 minus 0. 7 minus 7, 0. 4 minus 7 minus 3. 0. 0 minus 7 times of minus 3, 21. 1 minus 7 times of, this is where I made the mistake, I guess. 1 minus 7 minus 6. That's why I was having some doubts with that. So this was supposed to be minus 6. Because all of a sudden I'm just getting just one fraction on one side. So I had a small doubt with that. That doubt is clear. Please, I'm very sorry for that. So R2, now I'll just divide by minus 3. 1, 1, 0, 1. Minus 3, 1, that's minus 7. So that's going to be 2. Yes, finally, job done. I hope you can forgive me for that. I got carried away with this calculations and all that. Okay, so almost done. So now next my focus is all done. So 1, 0, 0, 1. So this I have to convert to 0 now. So that's, how do I convert this to 0? So that's going to be very simple. That's like R1 I can just use as R1 minus R2. So R2, no changes at all. Minus 7, 2. So R1 minus R2, where is it? 1 minus 0, 1. 1 minus 1, 0. Minus 3, minus 7. So that's like minus 3 plus 7. Minus 3 plus 7. So minus 3 plus 7, that's 4. The other one, where is it? 1 minus 2 minus 1. 1 minus 2 minus 1. Alright, yeah, thank you for understanding that. Mistakes do happen from everyone. So actually it's on the board now, so I just got carried away with that. Especially with this, that's 6. I just misinterpreted. So that's it. We have our final step here. So that's like, it's like A into B, I equal to B into A. So that implies A inverse is this matrix B, which is 4 minus 1 minus 7, 2. You can always check your authenticity also in the exams. You can always check, because how you will check is if you just multiply this A with this matrix B, you should get an identity matrix. So you can multiply with those two matrices. If you get I or your identity matrix, then definitely yes, your answer is valid. If you're not getting, when you multiply that matrix A with this matrix, if you're not getting I, then definitely there is some problem. Okay. All right. Okay. Now, all right, that's something here. Number 14. Okay, this is interesting. Yeah, actually, anyway. You see this matrix that is given to us, its inverse will not exist. Because it's a 2 by 2 matrix, so I could easily identify. You will also be able to identify that very soon after the next session, that's after determinants. You'll also be able to identify that very soon. So if it was a 3 by 3 matrix, maybe I also have to calculate, but it's not a 3 by 3 matrix, it's a 2 by 2 matrix, so that's why I could identify, because if you remember, see, if I go for this determinant, 2 to the 4 minus 4, so it's like 2 into 2, no? 2 into 2 minus 4 into 1, so it's like 2 to the 4 minus 4, you see, 0. So A inverse does not exist. So for a 2 by 2 matrix, it's very easy. Of course, we can easily predict also, because we can just cross multiply and check also. We have a drink of water. So that's how we can easily identify for a given matrix of order 2 by 2. So for this one, the inverse does not exist. Okay? Alright. Chalo, now let's try a 3 by 3 matrix. I hope you're ready for it. Karega shuru. Chalo, let's try 17. Brace yourself. Alright, so this is a 3 by 3 matrix. So how shall we focus on this matrix this time? Don't worry, for this also I have seen a trick which we can apply, which is also again very effective. Or otherwise, as I say, we can just focus on one row, convert 1, 0, 0. Move to the second row, convert 0, 1, 0. Move to the third row, 0, 0, 1. But again, another trick is that once you get one row, it becomes very easy, okay? Because once you just get one row, then the remaining rows will just come automatically. But like sometimes, as I say, it gets too messed up. So there's another trick. 2 by 2 matrix, I told you how to proceed. Now for 3 by 3 matrix, what you can do is, maybe this might work, so let's have a look. I'll start with this, then with this, then with this. Same. But after this, start with 1, then this, then this. But after this, I'm not going here. I'll go here. I'll focus on that. After that only I'll come to here. From there, rest as usual. Here, move up, come back here. Well, that's one of the ways, as I say. Again, it's not that I discovered it. No, it's not like that. But I've seen this, so this is also very effective. Or the other way is just focus on one row at a time, then move up. No, you get one row, then automatically the other rows will follow. So that's also the way you can do. But one problem is that most of the times we lose our focus, because especially with a 3 by 3 matrix, 2 by 2 though randomly also can be done. So we'll try to follow that, okay, because this is a nice way to do. Let's start. So I'll focus on this 1. So that means the second and the third rows I am not interested. Alright? Now, इसको कैसा करके 1 करेगा? Simple again. Will that do? Since there is no space here, I'm just writing it down here. Row 1, 5 minus 4 is 1, isn't it? 5 minus 4 is 1. So like 5 minus 2 times of row 1. I think that will do. So R2 minus 2 times of R1. So that will be, let's begin with the steps. I'll do here. You can see, I guess. So that will be, let's 5 minus 2 times of 2. So that's 5 minus 4. That's 1. This is 1 minus 2 times of 0. That's 1. This is 0 minus 2 times of minus 1. So that's like minus minus plus 2. So that's going to be plus 2. Let's do this. Again, R2 minus 2 times of R1. So R2 minus 2 times of R1 minus 2. R2 minus 2 times of R1. R2 minus 2 times of R1. So that's going to be minus 2, 1, 0. I'll just write down that 3 by 3 matrix here. So this is done. Okay, I'll rub off. I'll just write down this operation here. You also do, if you come across any mistake, do let me know. I hope this time I'll not make any mistakes. So 0 minus 2, 1, 0, 0, 0. Fine. Next is to convert this to 0. So what can I do is R2, I'll convert as R2 minus 5 times of R1. So R1 I won't be changing, R3 I won't be changing. So chalo, R2 minus, now I'm going to do directly. Okay, I hope you can catch it up because let's save some time. So 5 minus 5, that's 0. 1 minus 5 ones are 5. So 1 minus 5 minus 4. 0 minus 5 twos are 10 minus 10. Next again, 0 minus 5 twos are 10 minus minus plus 10. So 0 plus 10, that's plus 10. 1 minus 5 ones are 5. So 1 minus 5 minus 4. This is 0. So this is done. Next again, this step. This is already 0. So this is already 0. So I don't have to work on that. Good for us. Next, I shall focus on converting this as 1. That means this element. Again, very tempting. I can just divide by minus 4. So simple, so nice, so easy, isn't it? But remember, I'm reminding you again, try to avoid fractions. That's the last thing we want. It will slow down your calculations, I mean. So, okay, the other steps, other rows which I'm not interested, I will write. So next what I can do here is, I'll just write here R3, not R3, sorry, R2, without changing the other values again. Okay, you should not change these values again, otherwise again there will be Goldman. I need plus 1. So R2 plus 5 times of R3, will that be fine? Because in that case I'll have minus 4 plus 5 into 1. So that's like minus 4 plus 5. That will be 1. R2 plus 5 times of R3, and 0 won't be affected, isn't it? Because it's 0 plus 5 times of 0 still be 0. This of course will affect, but that's not what we are converting now, so no problem. So minus 10 R2 minus 10 plus 3 times of R3. Isn't it? R2, not 3 times, 5 times of R3. So minus 10 plus 5 3s are 50. So this will be 5. Where? Okay, this will be 5. Getting a hold of it now, slowly. Let's minus 4 plus 5 minus 10 plus 15, no problem. Now again continue with this. So 10 plus 5 times into 0, so that's like 10. Minus 4 plus 5, 0, again minus 4. 0 plus 5 into 1, so that's like 5. So I'm going to write this operation again here. Then I'll move to this. I need this as 0. Which is very simple. R2, no, not R2, R3. R3, I'll keep it as R2 minus R3, just to avoid the, I can do, see, done, 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 done. This to be 0 now. So I can easily do R2 minus R3, or I can do R3 minus R2, but I'll just try to avoid this negative sign, so I'll subtract 5 minus 3, 2. If I do like that, then it's 3 minus 5, that's minus 2, so I'm trying to avoid that also again. So this rows will not be changed. Second row also will not be changed. Third row I'm changing. 0 minus 0, 0. 1 minus 1, 0. 5 minus 3, 2. R2 minus R3. 10 minus 0, 10. Minus 4 minus 0, minus 4. 5 minus 1, 4. Okay, so this is also 0. Now moving on to this, that has to be 1. This has to be 1. So the first and the second row is not our concern. So what we can do is maybe see R3, if I just divide by 2, will it work? Yes, I do remember, I told you to avoid fraction. That's what I'm doing. Because here if I do divide by 2, no problem. 0, 0, 1. Here I divide by 2, no problem. Because see, all are easily divisible by 2, no problem. So yeah, no fractions here, so not a big deal. So this is also done. So again, now going back to this, almost there. You have to be patient. If you do it on paper, it's much easier. But since I'm doing on the board, it's kind of taking time. But don't worry, it will be very efficient also. So next, this is to be 0. This one. So the other rows, I'll write as it is. So this can be easily turned to 0 because R2 I can just write as R2 without changing the other values minus 5 times of R3. So R2 minus 5 times of, so this is done now. So this is just a distraction, I'm rubbing it off. Especially for me, it's on the board, as I say, very distracting. Chalo. So 0 minus 5 times of 0, chalo, whatever be it's 0. 1 minus 5 times of 0. 5 minus 5, 0. So it doesn't affect the other rows. You have to keep that in mind also. The other rows which you have already converted, try not to touch those. 10 minus 5 times of 5. So 10 minus 25 minus 15. Minus 4 minus 5 into minus 2, right? So minus 4 plus 5 2s are 10. So that's 6. 5 minus 5 2. So 5 minus 5 2s are 10. Minus 5. Okay? I don't need this now. So that is also done. Again, going back, I have to convert this to 0 again. Finished. I'm rubbing it off. Calculation, of course, you can just follow it up with the operations also. So next, my focus is on this to be as 0. So you can see R2 and R3 already done. After that, of course, you can apply any operation also. So what can be done? R1, I will do that with R1 minus 2 times of R3. So that the other values are not changed. So R1 minus 2 times of R3. R1 minus 2 times of R3. 1 minus 2, that's 1. 1 minus again 1. 2 minus 2, 0. Okay, minus 2 times of 5. So that's like minus 2 minus 5 2s are 10. So that's minus 12. Okay, this one. 1 minus 2 times of minus 2. So 1 plus 4, isn't it? 2 2s are 4 plus, so 1 plus 4. I'm being extra cautious now. 1 plus 4, because when you're almost there, that's where we always make the mistakes. 0 minus 2 times of R3, so minus 4. Let's hope that we're not making any mistake here. I cannot see because I cannot go back and check the other steps. So finally, we come to this to be 0. That will be R1 as R1 minus R2. I hope this is alright. R1 minus 2 times, so minus 5 minus 2 minus 2 5s are 10. That's alright. 1 plus 2 2s are 4. 5, 0, 2 2s are minus 4. That's alright. So ultimately, again, this is already done. So here I just need 0, so I'll just subtract. So 1 minus 0, 1. 1 minus 1, 0. 0 minus 0, 0. Minus 12 minus 15, minus minus. So minus 12 plus 15. That's 3. 5 minus 6, minus 1. minus 4 minus minus 5, so minus 4 plus 5, that's 1. So finally we have minus 3, 3 minus 1, 1, minus 15, 6, minus 5, 5, minus 2, 2. So ultimately we have the situation or the condition which verifies our proof. So that's I equal to B into A. So that implies A inverse is our matrix B, that is 3 minus 1, 1, minus 15, 6, minus 5, 5, minus 2, 2. So don't worry about this. As I said, yeah, it might definitely, sometimes it's quite, see, I'll not lie to you, okay? I will definitely not lie to you. It does get confusing for us also sometimes, right? As we solve, we have already seen, it's mistakes and anyone can do, okay? Anyone can do any kind of a mistake. Nobody is immune to mistakes, careless mistakes and all, but we just can't worry about that every time, isn't it? So I'm not going to be lying to you. I also make a lot of mistakes, simple mistakes, plus minus, where we are overconfident sometimes. So, but don't worry about that. You keep on practicing, but this is a procedure. If you follow that, I think this is also good enough. Otherwise, as I say, you can focus on row wise. That will also work. Different methods are there, not only one method. There are so many other methods. All right. So this is what we mean by elementary row operations. Yes, the videos on exercise 3.3 maybe in a day or two I'll be uploading those videos also for you. You can just check out, you can subscribe and check, give the notification bell also, you will get the notification. So solutions to exercise 3.3 will be given to you. I hope you have liked this video today. It was a very intense video, it was a new thing for most of you, so it was very interesting to teach also. So but this, as I say, it will depend on you, your practice only. So yeah, in the beginning I'm telling you there will be some confusions, you will find things a little bit, but as I say, stay focused, stay focused on your steps. You will find it easy after some time, maybe after 2-3 days, 4-5 days of practice, definitely it will come to you. All right, so that's it for today then, guys. Thank you so much for being with me here, for bearing me and all. Okay, so thank you so much. I really enjoyed today's session because I made some mistakes, you helped me out, so it was really nice. I really enjoyed it. So it was, yeah, thank you all for such beautiful comments, and also it's really heartwarming, so I really enjoyed it. Yeah, it's almost 1.5 hour session, so it was really nice. I hope to have more great times teaching you. Okay, so I love you guys. I'll see you again in the next session, that's with determinants. So yeah, tonight I'm going to wish you a very good night to each and every one of you. All right, so thank you all, thank you each and every one of you for joining. Sweet dreams each and every one of you, and yes, please do stay safe, wear your mask and take every precaution that you can. Okay, so all right then, thank you. It's good, it's nice actually, today was more interesting, wasn't it? So it was really nice to see all of you. All right then, I'll see you next with the next session, determinants. Okay, so bye bye guys, love you guys.